Hello, I am Mohuli Ganguly. I am in the 11th grade and I go to LaSalle College Preparatory in Pasadena. Today, I will be talking about my research and examining how different medications and electrolytes affect pluripotent stem cell to cardiomyocyte differentiation. So, these are the topics I'll be covering today. So first off, I would like to start with my hypothesis. I believed at the start of this experiment that if stem cells are treated with cardiac medications or electrolytes, then it is expected that the differentiation process of the cardiomyocytes will be affected in some way, whether it's positive or negative. We will find out. For my procedures, I did a standard stem cell plating procedure where I prepared the cell culture flasks, the growth medium, and then thawed and plated these stem cells in the plate setup. That took approximately 3 days. Following that, I did 8 days of medium changes, and during those 8 days, different electrolytes and medications were added to the cardiomyocyte differentiation medium. And then after that, on day 10, I did the antibody staining procedure, which is a 2-day process with the primary antibody staining and the secondary antibody staining. And we use TBX5 staining. So let's start with the results. I would like to start with metoprolol. This prescribed medication had very interesting results in the sense that the 10 micromillimoles of the medication had the most cell differentiation and cell yield. As you can see, there's a lot of cells right here on this plate, and that is confirmed by the amount of cell differentiation. If you can see right here in the right here, these markers are showing, these green lights are showing that the cell differentiated greatly. And what was interesting about this experiment is it had the most cell yield and most cell differentiation out of all of the electrolytes and medications. However, the 0.5 millimoles of metoprolol actually had the least amount of differentiation and yield. So the lowest concentration had the lowest yield, and the highest concentration had the highest yield for this specific drug, which is very interesting. So here again is the immunolabeling. This you can see a very, very slight bit of differentiation, but it's almost negligible. Then we have the 5 millimoles, which is very standard, and then the 10, which was out of the ordinary as it had a lot of differentiation. Next, we had aspirin. Aspirin was very consistent throughout its progression in the concentrations. However, it still did not differentiate as much as the other electrolytes did, especially compared to the metoprolol. So as you can see, this is again confirmed by the immunolabeling. There's just one little spot and a few other slight places where the aspirin concentrated cells differentiated, and then these two are very standard as well. They do not differ that much from the other electrolytes and medications used in this experiment. So as we discussed before, the metoprolol at 10 millimoles was high in cell yield, and it was low in cell yield for the 0.5 millimoles, even though they were the same drug that was used. Aspirin was the lowest in most consistent in its cell differentiation and yield, and so which is really a testament to the drug itself, because it is the only non-prescribed medication used. Metoprolol and digoxin, which was used in this experiment, are both commonly prescribed drugs, while aspirin can be found over the counter. Sadly for this experiment, the cells did not beat. However, this was not a cause of the additional supplements and electrolytes added. This was just because of other experiment errors. So my results showed that the addition of supplements to differentiating cardiac cells can cause a higher cell yield and more different cell differentiation for certain medications and supplements. And so this confirmed my hypothesis because all of the electrolytes and supplements and medications did affect the cells in some way or form. So thank you so much.